we continue trigonometry review. On question 35 and 36, we'll convert between the degrees and radians, or the radians to degree, either way. The conversion factor between degree and radian, we have 180 degrees equal to pi radian. So if we have negative 36 degree, that's where we start. And we don't want degree anymore. We're going to put one of these on the top, one of them at the bottom. Since we don't want degree anymore, we will put 180 degree at the bottom and the pi radian on the top. Degrees and degree cancel out, and we just have negative 36 divided by 180, that's like 1/5 pi, and then radian. That's the first one. So that is where we want to go from degree to radian. We multiply by pi radian divided by 180 degrees. Degree and degree cancel out, the radian will remain. The radian is a dummy unit. We can just take out the radian if we don't want to write it. Alright, next, pi over 3. Pi over 3 radian if we want to. Radian is not really a unit. We can just put it in and take it out whenever we want. Now, we want degrees. So we're going to put degree on the top. At the end, the answer will be in degree. We do not want radian, so we put the radian at the bottom. And radian cancel out, pi cancel out. 180 divided by 3 is 60 degree. The unit will remain. So that is how we convert between the radian and degree. Next, we have arc length. Length of an arc. We're going to have a central angle and the radius r. The central angles is very important. All the calculation involving the arc length or the area of a sector require that an angle theta, the central angle, have to be in radian. And if it is the case, then the arc length S is equal to the radius times theta. Right. So we have 75 degrees, the central angle. We need to convert to radian before we do any calculation. So the same ratio there. I don't want degree, so put degree at the bottom. Then will be pi radian on the top, or just pi. Radian or not, it doesn't matter. 75 divided by 180. So that calculator with me. That's 5 over 12. And then there's a pi still. The degree cancel out. Right, so that is 5 pi over 12. And then we just put everything we have in the formula. The radius is 8 centimeter. And the angle in radian 5 over 12 pi radian or not, it doesn't matter. So we multiply 8 times 5 over 12, we have 10 over 3 40, sorry, 8 times, yeah, so that's 10 over 3 pi centimeter. If we want to estimate 10 over 3 times pi, we have about 10.47 centimeter. So the arc length of an arc is equal to the radius times the central angle, and the central angle must be in radian. So that's all. Next we have the area of a sector. Area of the sector area of the sector. We still have the radius r and the central angle theta. As always, it will be in radian. Right? And the area of the sector, area is equal to 1/2 r square theta. Once again, the central angle is not given in radian, it is in degree, so we need to make the conversion. So don't need degree, so put degrees at the bottom and pi radian on the top. Yeah. It doesn't matter, maybe radian or not, it doesn't matter. Degrees cancel out. 20 divided by 180, so that is 1 over 9 pi, or just pi over 9. Sorry. So the area is 1/2. The radius 6 meters square. We may or may not put the unit here. I just work with numbers. And theta pi over 9. Right. So 6 squares 36 divided by 18. So that will give us 2 pi. Which is about 6.28. If we want to round to 1 decimal places, so alright, so that's what we need. Oh, the first one. Okay. The unit will be meter square, because we have meters times meter is meter square. Anyway, they want 1 decimal places, so let's just round to 6.3 meter square. Right. Next two, we have the application of the arc length and the area of a sector. Right. So first, the minute hand of the clock is 4 inches long. How far does the tip of the minute hand move in 20 minutes? So we have, see, that is the minute hand. If it moves 20 minutes, let's say if we go from the 12 o'clock here, 20 minutes, let's go to the number 4. This is still just 1 minute hand. It's just the same hand, but it will rotate. That will give us 20 minutes. So the minute hand is 4 inches long. And the question, how far does the tip move in 20 minutes? So that 20 minutes is this much. Alright, so in 20 minutes, we can just say that is 120 degrees. But if it will travel 1 revolution, so 1 revolution is equivalent to, I'm not going to say equal to, let's say it's equivalent to 60 minutes. So now we have 20 minutes. So that 3 times, so that will be 1/3 of that. Or we can say 2 pi for 1 revolution, 60 minutes. Now if we divide by 3 to get to 20 minutes, we'll divide by 3. So that's equivalent to 2 pi over 3. And that is the center angle. Yeah. If we don't want to, we can always set up the ratio. By this I mean theta times 60 is equal to 20. I mean the ratio is like this, 2 pi over theta is equal to 60 over 20. So that is the ratio we have, and we can solve for theta, which is 2 pi over 3. Right. So 60 theta equal to 40 pi, and the rest is simple. Anyway, so the 4 inches here is the radius, and this how far. So it asks for the distance or just the length of an arc. So we just use that. We have 4 inches for the radius. If we want to, we can always put the unit with the numbers. The angle 2 pi over 3 radian, or just without the unit. And so we do that. We have 8 pi over 3 inches. And let's just convert that. 8 times pi. At least I need to show on the calculator. Right. So on the calculator, we have a pi divided by 3. That 8.37. Round to 2 decimal places. Wait, sorry. Yeah, 2 decimal places. So that's about 8.38 inches. Right. Next, a sprinkler rotates to an angle of 145 degrees. So we have that already. So theta equal to 145 degrees. Of course, we convert this to radian for sure. While spraying a stream cover the distance of 35 feet. What is the area? So we need to find the area of the sector. So the sprinkler look like this, and it rotates an angle of 145 degrees, and the stream of water covering the distance of 35 feet. So it rotates in that sector. And as for the area, this area, So 35 feet, of course, is the radius. Right. So first 45 degrees, let's convert that to radian. Pi 180. So 145 divided by 80, 180. 29 over 36. 29 pi over 36. Right. Area of the sector. 1/2 r square theta. 1/2. We can just put the feet with the number. And the angle is 29 pi over 36. Right. I'll just do all of that calculation. Calculator. 1/2, or you just say 0.5 times 35 square times 29 pi divided by 36. We have about that 1550.07, and we have feet times feet, so be square feet. Right. As a reminder, there will be the timestamp in the description, so that's why I recording the time, FaceTime. So that is 40. Next we have the angle, the trig values for the angle in radian. We'll do 42 only, 41, 41, 42. Right. So 11 pi over 6, of course we have the unit circle and all, but a nice trick about this is we just say that equal to, could be plus, could be minus, but it's going to be equal to a reference angle. So reference angle of 11 pi over 6. So reference angle of 11 pi over 6, it's just pi over 6. So everything is multiple of pi over 6. I mean that I should not say that. If there's a 6 at the bottom of pi over 6, then that will be a reference angle is pi over 6. If it's pi over 3, then the reference angle will be pi over 3. Right? If the fraction is reduced, if it's not reduced, we cannot use it. So it is reduced. So pi over 6. So we say that we equal to cosine of the reference angle pi over 6. Next we will determine if it is positive or negative. 11 pi over 6. So we can use the calculator. I just need to show that. So what we have is 11 over 6. So it is 1.833. So originally we start from 0, will be here, back to pi will be here, and then 2 pi will be at 0 again. 1.833 is about here. So this is in quadrant 4. In quadrant 4, x is positive, therefore cosine is positive. So we're going to have the sign here, it's going to be positive, cosine pi over 6. And finally, we just do cosine pi over 6. That is square root of 3 over 2. Right. Next, this is divided by 2 and that fraction is reduced. If it is multiple of 2, 3, 4 or 6, then we just say the reference angle is very easy to determine. Will be just pi over 2. By the way, that is cosecant, right? Not cosine, sorry. Right. By the way, yeah, we're going to do that later. Let's try this again. Cosecant of negative 5 pi over 2. Cosecant is 1 over sine. Right. So we're going to find sine of negative 5 pi over 2. Right. We should start with that first because this is cosecant. Right. I will do the same thing. Reference angle is pi over 2. So this is going to be sine. Right. Next, we determine the quadrant. Negative 5 over 2 is negative 2.5, I know, but so 0, pi, back to 2 pi, and 2.5 pi is right there. So right there y is positive, so sine is positive. Sine in this point is positive. Except this time we go with the negative direction. Sorry about that. So 0, negative pi, negative 2 pi, and negative 2.5 pi. So this should be negative because here y is negative, so sine is negative. Sorry about that. We have the negative direction. Right. So we have sine pi over 2, which is 1. So this is just negative 1. So we have 1 over negative 1, which is negative 1. Right. Right. Next, we will have the angular speed and the linear speed. So I will write the formula here first. So angular speed is omega equal to the change in the angle over the change in time, and the linear speed is the distance divided by velocity. I mean velocity equal to the distance given by the arc length divided by time, and the relation between the two is v, the linear speed, equal to r times the angular speed. So that's what we have. Right, the angle is in radian already. If there's no unit, it is in radian. Right, find the angular speed. So this one's straightforward. Omega is equal to theta over t. Theta is pi over 2 divided by 11 seconds. So pi over 2 divided by 11. Pi over 2 divided by 11. We have about 0.14. Or just pi over 22, or we just have 0.143 radian per second. Radian is a nice unit, so we can always put in the radian or take it out when we need to. So let's write the radian. Then we have radian per second. So that's what we have. Right. Next we have two examples here. A wheel rotating 4 radian per second. So we'll underline all the numbers and units. 4 radian per second. 6 inches in diameter. Well, watch out that this is the diameter and not the radius. To the nearest foot per minute. What is the linear speed? Right, so they ask for the linear speed. So first of all, 4 radian per second. That is the radian is the measure of the angle, and second is the unit of time. So we have theta over t, which gives us the angular speed. So the angular speed is 4 radian per second. And the diameter is 60 inches. Cut that in half. We have the radius of 60 inches. Divide by 2. So that would be 30 inches. I should say 60 inches divided by 2. Right, 60 inches divided by 2. 30 inches. Right. The little twist in the problem, they want the nearest foot per minute. So we have to convert the unit. 1 foot is 12 inches. So we don't want inches. So we put at the bottom. So it will cancel out. 30 divided by 12. We have 5/2, which is 2.5 foot. Omega, we can write 4 radian per second, right? We need to have in minute, so we convert this to minute, right? Since we don't need the second anymore, we need to put the second on the top, so it will cancel. And the relation between the second and the minute, of course, 1 minute is 60 seconds. So the second cancel out. 4 times 60, so that is 240 radian per minute. And finally, they ask for the linear speed. The linear speed is v r times omega. The radius is 2.5 feet. Omega 240 radian per minute. So 2.5 times 240, we have 600 feet per minute. The radian, we can just take it out when we don't need. So we have feet over minute. Right. Next, we have the rear wheel of a long tractor has 13-inch radius. So we have the radius 13 inches. 13 inch. Find the angle through which a wheel rotates 21 seconds if the tractor is traveling at the speed of 14 miles per hour. So miles is the distance or the length. hour is the unit of time, so miles per hour, s over t, which is velocity. So we have velocity of that. But first, through which angle rotate in 21 seconds, so that is t. And we have excuse me, and we have v equal to 14 miles per hour. Right. And the question is find the angle. So they ask for the angle, so that's straightforward. Right. So we have v, and then certainly we can go to omega. So there are a few ways to do this. Let's just write all the formulas that we can use. V, the linear speed, equal to r times the angular speed. So from here we can convert to the angular speed. And then the linear speed by itself is the arc length over time. And then omega equal to theta over time. And if we want the arc length, s is equal to r times theta. So all of those we can use. So first, what I'm going to use is, I'm going to use this one. We have the time, we have the velocity, we can find the arc length. And finally, once we have the arc length, we can use this formula. The arc length, knowing the radius, we can find the theta. Right. The only problem here is there are a bunch of different units. So first, 14 miles per hour, we have to convert that into inches a minute. Right. Inches and second. Right. 14 miles per hour. So I will write 14 miles per 1 hour. And then will be a bunch of unit conversion. First, I don't need hour. We need to be in second. So 1 hour, we can say 60 minutes. And 1 minute is 60 seconds. So the hour we cancel out, the minute cancel out, and we have that. Finally, we don't want the mile, we want inches. So different conversion unit. So 1 mile is equal to 5280 feet, sorry. And 1 foot is 12 inches. We cancel the feet and the mile. Finally, we just do all the numbers, and then the unit will be inches per second. Right. So I just do this calculator. 14 times 5280 times 12 divided by 60 times 60, which is 3600. Right, we have 246.4. That will be inches per second. Right. Sorry, I just put the calculator away. So we have that. Now we have the velocity or the linear speed. So V equal to S over T. So S, the arc length, equal to V times T. V is 246.4 inches per second times 21 seconds. And the second and second cancel out. So 246.4 times 21. We have 5,174. .4 inches. And finally, the arc length formula, S equal to R times theta. So theta is equal to S over R. S is the arc length, 5,174.4 inches over the radius of 13 inches. So we divide that by 13 and we have 398. And we can always, this is the measure of an angle, so we can use the radian as a unit. Just add the radian into it. Right, so that is 45. Right. So with that, we go to the next part of the review will be straightforward. Right. So provide the requested information about the circular function. So we have sine. So on the unit circle, the unit, so the radius is 1. Whenever we have a point, there will be the x and y coordinate. The x values is the cosine, and y values is the sine for this central angle. But we write sine of an angle. So it is very easy to see that doesn't matter where the point is on the circle, there is always the x values and the y values. So the y values is always as this. Y value is always there regardless of the angle. So in this case, the domain is all real numbers. So the domain of sine, cosine are all real numbers. So for those two, domain is all real numbers. Which we can write negative infinity to infinity. So domain of sine, cosine, all real numbers. For all the trig function, the denominator cannot equal to 0. But for sine, cosine, it's always defined. Right. So the domain of secant. So we write secant is the reciprocal of cosine. So pretty much whenever cosine is not equal to 0, that is where the secant is defined. Again, we have a unit circle. Cosine, remember, is the x values. So the x values equal to 0. So cosine of something equal to 0. We cannot have these values because those points the x values at those points are 0. X equal to 0, cosine equal to 0, divided by 0 is undefined. So x cannot equal to this point here, or 3 pi over 2, 5 pi over 2, and so on. In general, we can write x not equal to pi over 2, which is here. We can add a pi to it, or 2 pi, or so on. So we just say plus n pi. So when x not equal to pi over 2 plus n pi, not those 2 points, cosine is not equal to 0, cosine not equal to 0, then 1 over cosine is defined. So denominator not equal to 0, the function is defined, and so we don't want that. We want denominator equal to 0. Next we have both the period. As far as the period of the circular function, we have this, the period of sine, cosine, and their reciprocal, which is secant and cosecant. By default, which is x, will be 2 pi, and for tangent, or cotangent, is a pi. So sine, cosine, secant, and cosecant are 2 pi, and tangent and cotangent just a pi. So this one easily cosine, so that will be 2 pi, and cotangent, that's just a pi. Next, what are the asymptotes of y equal to cotangent of x? Right. We will write y equal to cotangent of x. Cotangent is equal to cosine over sine. Now, similar to the, actually, I should not say similar, it should be complement to the domain. Domain is where the function is defined. The asymptote is where the function is not defined in terms of circular function. So we need this function to be undefined, meaning that the denominator equal to 0. That's where we find the asymptotes. For circular function is where the function is undefined. So we look for where sine is equal to 0. Again, on the unit circle, sine is the y values. The y value is equal to 0 will be here and here. So we need to have x equal to those points, which is a multiple of pi. So it could be 0, pi, 2 pi, negative pi, and so on. In general, we just say x equal to n pi. So that is 15. Right, next, find the amplitude and the range of the function. So I will write this note before we do anything. Only the sine and cosine function has amplitude. And in particular, for y equal to a sine x or a cosine x, amplitude is equal to absolute values of a So in this case, the amplitude is -3. I mean absolute value of -3, which is 3, meaning that it will be 3 up and 3 down. So the range will be from -3 to 3 inclusively. Right. Next we have the period of these two functions. Alright. Keep this in mind. For sine x, cosine x, the cosecant and secant x, the period is 2 pi. Tangent, cotangent is a pi. Alright. So we're going to use that. So the first one, find the period of this function. So by default, the period is going to be 2 pi for cosine. However, on this problem, we have the coefficient of x. So we always divide by the coefficient of x. So that gives us 2 pi over 5. So pretty much just that. So it's going to be 2 pi for just x. This divided by the coefficient of x. The coefficient of x is 5. Right, so that's just that. Next, the period is cotangent of -3. We can also say just pi or 2 pi divided by -3. Before we do that, we need to do one little things here. It's the even and odd function. So even function, the function that are even is cosine of x, and the reciprocal will be the secant of x. Those are even. The odd function will be sine. Reciprocal of that is cosecant tangent x. Reciprocal of that cotangent of x. So how's that significant? Because here we have negative. Because cotangent is negative, meaning that the negative here, for every odd function, we can take negative, moving outside. That only works for the odd function. If it is an even function, then would the negative just disappear. For example, we can write cosine of -x is the same thing as cosine of x. An even function, that negative just disappear. So we have that. And finally, we have the coefficient of x is 3. Now go back to what we have here. For tangent of x, the period is a pi. So we're not using 2 pi. 2 pi is only for sine, cosine, secant, and cosecant. For cotangent or tangent, it's going to be a pi divided by the coefficient of x is 3. And that gives us the period. So the period is either pi or 2 pi divided by the coefficient of x. And where we use pi or 2 pi is from there. Right, now we start to graph the trig function. Right, y equal to cosine of 1/2 x. So to graph this, we're going to write the amplitude. Now I will list them. So the amplitude period and then phase shift and vertical shift. Right. So the amplitude will be whatever in front of the trig function. So this case is just 1. So the amplitude is equal to 1. The period equal to, this is cosine. By default, the cosine is 2 pi. But we have to divide by the coefficient of x. Divide by 1/2. So will be 2 pi multiplied reciprocal. That gives us 4 pi. Well, it's not going to look nice. Right. The phase shift, we just let inside the parentheses equal to 0. So just x equal to 0 or no phase shift. And the vertical shift, there's none. If there's add or subtract some number, that's the vertical shift. So here we say none, or we can say y equal to 0. Right. So now we graph. Right. The period is 4 pi. So this is bad here, very bad. So if that is 2 pi, so trying to measure the same thing. So let's see. So that is almost 1 inches. So say that would be about here. So that is 4 pi. So that is for one period from 0 to 4 pi. Right. And once we have that, we'll divide into 4 equal segments. So 2 pi will be in the middle. 4 pi, 2 pi, and then a pi, and then here will be 3 pi. Right. So the period is 4 pi. Cut that into 4 equal segments. And then the amplitude is 1, meaning that the graph is going to be between -1 and 1. So 1 and -1. So this gives us an amplitude. So this one is the amplitude, either that or that. Right. And then finally, this is the graph of cosine. And cosine, the parent for cosine is, we start with the max, go back to 0, mean 0, and then max. So max 0, mean 0, max. That's why I draw in pencil. Right. Since the graph cut up about here, so we just need to have, and then we just copy and paste this parent. So from here, look like it's going to be minimum 0. So that's the graph. So we have the graph. Like that. Right. So that is 54. So when we did to graph the trig function, we just need to identify all of this, and then we can graph. On the test, you won't have this situation where you have to do that. The scale will be blank. More likely you will have something like 63 or 64. Is that right? 55. Amplitude. Would be absolute values of -3. The period by default is going to be 2 pi. divided by the coefficient of x, which is 2. So the period is 1 pi. Alright, again, the scale is very bad here. Alright, this one we don't have any phase shift or vertical shift. Right. Now, first the amplitude is 3, so it will be 3 up, 3 down. So that much we know. So the amplitude is from the central line up and down the same unit, same number. Right. The period is pi. So from 0 to pi, so this is 1 period. And this is the sine pattern. So the sine in general is 0 max, 0 mean, and then back to 0. And the negative sign, this one has the negative. We're going to flip this upside down. 0 is still 0. Max become mean, and mean becomes max. So we start from 0, and up here we have to divide into 4 equal pieces. So cut it in 4 equal segments, and we go from 0 to minimum. So look like here, back to 0, and then maximum, and down to 0. So we're going to have again, I should draw this with pencil. So that is 1 period. Once we have 1 period, we can just copy and paste. For every period, going down, that better, and then just copy and paste throughout the whole interval. Now the graph of the tangent. Right, amplitude. Tangent has no amplitude, so that doesn't help at all. So we say tangent has no amplitudes. So we don't need that, because we don't have it. Right. So we don't have the amplitude, so we cannot use that. Right. Now focus on the 4 actually doesn't do anything here. It's stretched a little bit, but it doesn't help. The tangent of 2x, I will write this as the sine of 2x, and then cosine of 2x, because tangent is equal to sine divided by cosine. And to graph the tangent, all we need to do is determine the tangent, determine the asymptotes, and then tangent is an increasing function. So that's all we need. So we need the asymptotes. So where the cosine equal to 0. Right. In order to do that, let's say it, now let's take a look at a function y equal to cosine of 2x. The period of this is 2 pi divided by coefficient of x, which is a pi. So the period is a pi, and the pattern for cosine is cosine, start with the max 0, min, 0, and max. So if this is pi over 2, the same thing, so that's about, okay, about here, that is a pi. And so the cosine, again, we don't worry about the amplitude here, so we start with max, could be anywhere, but it will get to 0 a quarter of the way, so it will be here, and then minimum doesn't matter where it is, and then it get back to 0, and then go to the max. We don't need the maximum, the minimum, we just know that the values when the cosine equal to 0 will be at this point and this point, which is halfway. So we can say that cosine equal to 0, that when x equal to pi over 4, 3 pi over 4, and so on. So those 2 points. So we find out where the bottom equal to 0. For that we find out what is the pattern of the cosine, which is max 0, min 0, max. So 0 and 0 will be at those points. So when we have those points, that gives us the asymptotes. So that's where the function is undefined, where the denominator equal to 0. So we have the asymptotes here. And halfway here. And the cosine function is increasing. So we just said the asymptotes, so it is increasing, approaching to the asymptotes. There will be one here, so that look like it's going to go there, and yeah, let's say like that. So that is the graph of tangent. The tangent, all we need is the asymptotes. Asymptote is where denominator equal to 0. So that's why we find out where the denominator equal to 0. And one important fact is that the tangent function is increasing. Is increasing on each cycle. Cotangent is decreasing. Right. Now go to 57. This is the graph of secant. Right. So first, I will write 2 times 1 over secant is reciprocal of cosine. Right, so I'm going to write like that. However, we still consider the 2. So what we're going to consider when we do the graph is consider the graph of y equal to, we still have the 2, that gives us the amplitude, and then cosine 1 over 3x, even though it is 2 times 1 over cosine, but we're just going to graph the reciprocal function along with the number in front for the amplitude. So if we can graph that, we can graph the secant. Right, so for this function, the amplitude is equal to absolute value of 2, which is 2, the period by default is 2 pi, but we have to divide it by the coefficient of x, which is 1/3. 2 pi times reciprocal give us 6 pi. So that is a period. So from 0 to 6 pi is 1 period. Right, amplitude is 2, so we'll go up 2, down 2. And then the period is 6 pi. So every time we have a period for sine and cosine, we're going to divide this into 4 equal pieces, 4 equal segments. So 6 pi, halfway will be 3 pi, and halfway will be 1.5 pi. So we have that. And then the pattern of cosine. For cosine, the pattern, we start from max, 0, min, 0, and then back to max, which is maximum 0, minimum 0, max. So the graph of cosine is that, and then we can trace the other direction. Right. Whenever the cosine equal to 0, that's where the denominator equal to 0, we will have the asymptotes. So the asymptotes be right there and here. And whenever the function cosine equal to 0, we have the asymptotes. And once we have that, the graph of the 2 secant of 1 over 3x will bounce off the maximum and bounce up the minimum. So pretty much from the maximum approaching to the asymptotes. This point. And this point. So that is the graph of secant. Will be bounce off the sine cosine. So we always graph the reciprocal function. In this case, will be cosine, and then just bounce off the maximum and minimum. And we do have the asymptote. Asymptote is wherever the reciprocal function equal to 0. So that's what we have. Right. Write the equation A equals sine bx, the sine function. So this is a sine function given amplitude and period. Oh, so this will be pretty much that. So the amplitude is 4. And then sine, we don't know what this is, but it's going to be x there. Right. So whatever, of course that's going to be b for now. Later on we determine what is b. Right. Whatever b is, we know that the period is equal to 5 pi, and by default the period is equal to 2 pi divided by the coefficient of x is b. So pretty much what we have is this. So multiply or cross multiply, we have 5 pi b equal to 2 pi, divide by 5 pi on both sides, b equal to 2 pi divided by 5 pi, so it's 2/5. And we can try the same thing on 59. Right. Now on to 60. Let's take a look at 60 in general, 60 and 61. The first one, 60, we have the pivot 2 minus pivot 2 inside the parentheses. Inside the parentheses give us the phase shift. This is, if we want to be clear, we put the parentheses around this. So we do cosine of x first, then we plus 2. This gives us the vertical shift. This gives us the phase shift. This is the vertical shift. Alright, 60. Regardless, we still need to do all of those things. Amplitude, which is 1 because the coefficient of x here, the number in front of sine is just 1, so that's the amplitude. Period. By default it is 2 pi, and the coefficient of x is 1, so 2 pi divided by 1 is going to be 2 pi. Right. Next, the phase shift. This time we do have the phase shift. The phase shift is wherever we let the argument of the function equal to 0, x minus pi over 2 equal to 0. So x equal to plus pi over 2, we have pi over 2. So this is the phase shift. We don't have any number that is add or subtracted from it. Like 61, we have plus 2, so that means the vertical shift is plus 2, meaning 2 units up. Here we have pi over 2. Right. So the amplitude is 1, so that means the graph is between negative 1 and 1. So between negative 1 and 1, that gives us, that's the amplitude. The period is 2 pi, but it's not from 0 to 2 pi. The phase shift is where it starts. It starts pi over 2. So if this is pi, pi over 2 is halfway there, so it will be here. So this is pi over 2. That's where the phase shift is. We start a cycle at pi over 2. And then we go 2 pi. Right. So look like here's 2 pi is 1, 2, 3, and 4 ticks. So 4 ticks or 4 units is 2 pi. So we need to go 1, 2, 3, let's say 4. That will be 1 period. So that is where we start, and this is the length of 1 cycle or 1 period. If we want to know what this point is, all we do is just add a period to it. 2 and 1/2 give us 2.5, which is 5/2 pi. So this is 5/2 pi. Right. So, and then when we have a period, divide that into 4 equal segments. We have that, and the pattern for sine function, 0 max, 0 min, back to 0, 0 max, 0 min, back to 0. So that is the graph of the sine of x minus pi over 2. And then we just copy and paste this throughout the whole interval. So 1, 2, 3, 4 ticks. That's another period. 0 max, 0. It's a good idea to draw in pencil. So that's what we have. We'll just keep continue if we need to. Right. So that is the graph of that function. Next, cosine of x plus 2. So if we want to cosine in general, it's going to be this. I'm going to draw very light here. And this is plus 2, so I just have that 2 unit up. But let's just write all the details here. So amplitude is 1 in front of the cosine, don't have anything, so the coefficient is 1. Period by default is 2 pi, and divide by coefficient of x, which is 1, so it's still 2 pi. Phase shift, we just have the argument of the function, so which is x equal to 0, or we can say no phase shift. And then the vertical shift, we have the plus 2 here, which means 2 unit up. So we will have the phase shift at 2. I mean the vertical shift at 2. So this is where we have from 2. So that is the vertical shift up 2. Right? The amplitude is 1, which means from that phase vertical shift we go up and down 1 unit. And then from 0 to 2 pi, is the period. So we'll divide this into 4 equal segments, here, here, and here. Cosine is, I'll just write that every time. Max 0, min 0, and max. Max 0, min 0, and max. As we see, it's just like this graph moving 2 units up. And we'll just copy and paste. So that's what we have. Next, just find the phase shift of this function. So remember, just pay attention closely when we have the, it's not just x minus pi. We have to take the whole thing, because the function is sine of 1/4 times x minus pi. So in order to find the phase shift, we're going to let this equal to 0. So 1/4 x minus pi equal to 0. And so for x, multiply by 4 on both sides, x minus pi equal to 0, or x equal to pi. So there's still the 1/4 there. Right, next, the graph of the function y equal to -2 sine of 4 x plus pi over 4 minus 1. So we'll go through all of the steps. So the amplitude, absolute values of -2, which is 2. And then the period. Notice that we have to consider the 4 here. So I should multiply the 4 inside. So before we do anything, going further, I put a parenthesis or a bracket there, and then multiply it inside. So this becomes the function of -2 sine 4x 4 and 4 be plus pi minus 1. So we should do that. It will be easier to see. So remember, sine of 4 times x plus pi over 4. So sine up the whole thing there. So we're going to multiply the 4 inside. And that's what we have. So the period is by default is 2 pi divided by the coefficient of x, which is 4, so pi over 2. On this one we have the blank graph, which is good. We can choose the unit whatever we want. The phase shift, we're going to let this equal to 0 for x plus pi equal to 0. So when for x equal to negative pi, so x equal to negative pi over 4, that is the phase shift where a cycle starts. Vertical shift, we have -1, which means 1 unit down. Right. Now, so first, the graph is 1 unit down. So let's go with the vertical shift first. One unit down. We can choose any number we want, but we can choose 1 unit to be 1 or 1 tick to be 1, or if we choose 1 here, that's perfectly fine. But I'm just going to say -1 here, because after all, we need the amplitude of 2, meaning go up 2 and down 2. So that is the vertical shift where a cycle starts. I'm sorry, where the middle line is. And then go up and then down from there. All right. Amplitude 2, so 2 up. So the vertical shift and the amplitude will determine the y component or the vertical component of the graph. If we start from -1, go up 2 units, that would be 1. Go down 2 units would be -3. Right, phase shift. Right, we don't have anything on the axis, so we can choose pretty much. Let's choose pi over 2. We can choose this to be 8 unit or 2 or 4 unit, a multiple of 4. So let's say we're going to choose that to be 8. Let's just say 4. 4 or 8 will be fine. I choose 4 units to be pi over 2. So 1, 2, 3, 4. That is pi over 2. 1, 2, 3, 4. 1, 2, 3, 4. That would be pi. Right. Where do we start? Phase shift, -pi over 4. So if this is pi over 2 is 4 ticks, pi over 4 will be 2 ticks. So this is -pi over 4. And we're going to start there. negative pi over 4. Pi over 2 is that much. Pi over 4 is half of that. Right. A period is 4 units, so we're going to go 4 units. 1, 2, 3, 4. So this will give us 1 period. So the phase shift is where we start here, and the period of pi over 2 is this length. So the graph will fit inside that box, and I will just copy and paste throughout the interval. Oh, this one we only graph 1 period. So that's all we need, the graph inside that period. So don't need to copy and paste. Right. This is negative sine. So sine 0 max, 0 min, back to 0. Negative sine 0 still 0, max become min, min becomes max, and 0. So 0 divide this into 4 equal segments. 0 min, 0 max, and back to 0. So 1 period will be that. Right. I'm going to let you do this one, but again, if there's a 2 like this, I would multiply it out inside. So I have 2x. 2 times pi over 6. 2 times 1 over 6 is 1 over 3. So that's just pi over 3. So I let you do this problem. Right. So be that. Right. Do 65 instead. Right. Negative 3. Cosecant is the reciprocal of sine. So what we're going to graph, we will consider the graph of y equal to still negative 3 sine of x plus pi over 4. Right. We graph the reciprocal function. Right. All the step will be there. Amplitude, absolute value is negative 3, which is 3, period. By default is 2 pi. Divided by the coefficient of x. Phase shift. I'm going to let that equal to 0. Which is negative pi over 4. And vertical shift, there's none. And because that is negative sign, so the pattern will be this 0 min, 0 max, 0. Right, so first vertical shift is none, so that will be the x-axis. amplitude is 3, so 3 up and 3 down. Right? The period is 2 pi, starting from negative pi over 4. Right? So if this is pi 2 unit, half of that is pi over 2, half of that is pi over 4, and it's negative. So actually we're going to have to do that. So here is negative pi over 4, and that's where the cycle starts. And the period is 2 pi, so we're going to go 2 pi from there. Right, so for tick is going to be a pi, so it's going to be a tick will be 2 pi. So we have 1, 2, 3, 4. That is the midpoint. 1, 2, 3, and 4. That length is 1 period. The 2 pi here, we choose that to be 8 ticks. We have to divide this into it take to be cut that in half. Right, so that will be 1 period there. Right, and the pattern of negative sign, so sign is 0 max, 0 min, and 0, and the negative sign 0 min, 0 max, back to 0. I think on 65 we only need to graph 1 cycle, so only from negative, only 1 cycle here. Right, let's graph this the sign of negative sign first. So 0 minimum, 0 maximum, back to 0. So that is the graph of the negative sign. And now we go back to cosecant. Whenever it is equal to 0, that's where we have the vertical asymptotes. So the vertical asymptote will be where the function equal to 0, where the reciprocal equal to 0, that is. So those are the asymptotes. And then the cosecant is bouncing off the maximum and the minimum, but have to be between the asymptotes. So that's what we have. Now we go to 66 and 67. Alright, 66 and 67 we don't have the function, but we do have the graphs. So in this case, we still have to do the same thing. The amplitude, the period, even the phase shift and the vertical shift. Well, this one we don't have the phase shift or the vertical shift. Right. Look at this graph. At 0, we start from the maximum, so that looks like it is a cosine function. We need to have 1 period, so look like the period of that is a pi. So here, a period is a pi. So the pattern for cosine, let's just check. We have maximum, 0, minimum, back to 0, and then that is the max. So it's good. So this is definitely the graph of cosine of x. There's something there. Let's say that b. And let's say the amplitude is going to be A. Phase shift, we have none, or no vertical shift. Right. So since it go up 5 units, the amplitude is 5. So this is y equal to 5 cosine of that to be determined. The period, we go from 0 to pi, so the period is equal to 1 pi. But in general, to find the period, we take 2 pi divided by the coefficient of x, which we don't know. We call that b. So write the ratio cross multiply b pi equal to 2 pi divided by pi on both sides, b equal to 2 pi over 2 over pi, which is 2. So the graph will be, the function will be 5 cosine of 2x. The next one will be very similar. Look like we start from 0, so the pattern that start from 0 look like it's going to be 0 max, 0 in mean, and 1 period is a pi. So amplitude, period, amplitude 3 up 3 down, so that is 3 period a pi. Same thing on the previous problem. By default it is 2 pi divided by the coefficient of x. Alright, by the way, since it is 0 max, 0 mean, back to 0, it's going to be sine. The amplitude is 3, so the 3 will go down. Let's try this. Let's use that, put b for the coefficient of x, and then we show for b similarly, b will be 1/2. So the sorry, 2, I don't know why, sorry. So we have y equal to 3 sine of 2x. So knowing the period and the amplitude, we can put in this function. If we have the phase shift and the vertical shift, it will be a little more complicated, but we don't have it for this problem. And with that, we finish this review. Thank you for watching.